hybridization of elements having d orbitals. Okay. Elements present in third period contains s, p and d orbitals. Okay. So, energy of 3d is comparable to 3s and 3p. Okay. Also, 3d is the energy of 3d is also comparable to 4s and 4p. Okay, but there is a great difference in energy between this 3p and 4s. So, such hybridization is not possible. Okay, so hybridization takes place between 3s, 3p and 3d. These are having almost comparable energies, and 3d, 4s and 4p. These also are having comparable energies. Now, let us discuss some hybridization in the case of d orbitals. So, first hybridization dsp2. Here 1d, 1s and 2p atomic orbitals hybridized and form 4 dsp2 hybrid orbitals. These are directed towards the corners of a square planar. Okay, so the shape of the molecule is square planar and the angle between the orbitals are 90 degrees. Okay, examples NiCN2 minus, PtCl4 2 minus. Second one, sp3d hybridization. Here 1s, 3p and 1d atomic orbitals hybridized and form 5 sp3d hybrid orbitals. These 5 sp3d hybrid orbitals directed towards the corners of a trigonal bipyramidal. Okay, here 3 orbitals are in one plane, which are in a trigonal plane, making an angle of 120 degree. The other 2 orbitals are above and below the plane, okay, which makes an angle 90 degree with this plane, and the shape of the molecule is trigonal bipyramidal. Example PF5 and PCl5. Now the third hybridization is sp3d2. Okay, here 1s, 3p and 2d atomic orbitals hybridized and form 6 sp3d2 hybrid orbitals. Okay, these are directed towards the corners of an octahedron. Okay, in which 4 orbitals are in one plane. Okay, that is square planar plane. Okay, the other 2 above and below this plane. So this makes the shape of the molecule octahedral, and all the angles are 90 degree. Okay, example SF6 CONH3 6 times 3 plus CrF6 3 minus. Okay, this is some of the hybridization of elements having d orbitals. Now let us discuss one by one. First one, sp3d hybridization. 1s, 3p and 1d orbital hybridized and form 5 sp3d hybrid orbitals. These are directed towards the corners of a trigonal bipyramidal, and the shape of the molecule is trigonal bipyramid. Okay. Example PCl5. We can explain with the help of PCl5. Okay, here the central atom is phosphorus and its electronic configuration is 1s2, 2s2, 3s2, 3px1, 3py1 and 3pz1. Okay, so we can take the last shell. Okay, last 3s and 3p shell. Okay, that is valence shell. P ground state will be equal to like this 1, 2, 3s. Okay, 1 electron each in 3px, 3py and 3pz. Okay, and d orbital is vacant like this. Now in the excited state, 1 electron from this 3s shifts to 3d. Excited. Okay. Electronic configuration 3s, 3px, 3py and 3pz. Okay, so 1 electron shifts to d orbit, 3d orbit. Okay, now these 5 orbitals S, 1s and 3p and 1d orbital hybridized and form 5sp3d hybrid orbitals. Okay. These 5sp3d hybrid orbitals overlap with the p orbital of 5 carbon atoms. Okay. 5 chlorine atoms. Okay. Hybridized with p orbitals of 5 chlorine atoms and form 5 PCl sigma bonds. Okay. This is represented like this. Okay. So 3 PCl sigma bonds are in one plane, which are in trigonal plane. Okay. And 2 are above and below the plane. So this will be the structure, and the structure of the molecule is trigonal bipyramid. Okay. The angle between these will be 120 degree. These are on the same plane, and those which above and below make an angle of 90 degree with this plane. Okay. And the shape is trigonal bipyramid. And those bonds which are in the trigonal plane are called as equatorial bonds. These are equatorial bonds. Okay. And those above and below the plane are called axial bonds. These axial bonds, these are having more repulsion. This suffers more repulsion. Axial bonds suffers more repulsion. Okay. So they will elongate a little. So they are longer than equatorial bonds. Okay. So axial bonds are longer. So they are weaker bonds. Weaker bonds means axial bonds are highly reactive. They are more reactive. So due to the presence of these axial bonds, PCl5 compound is reactive compound. Okay. So this will be the shape of the molecule, and sp3d will be the hybridization of PCl5. Okay. Next hybridization sp3d2. Here 1s, 3p and 2d orbitals hybridized and form 6sp3d2 hybrid orbitals. These are directed to the corners of an octahedron, and geometry is octahedral. Example SF6. Here the central atom is sulfur. So sulfur ground state. Be like this. 2 electron in 3s. Then 2 electron in 3px. Then 1 electron in 3py and 1 electron in 3pz. And d orbital is vacant. In the excited state, 1 electron from 3s and 1 electron from 3px shifts to 3d. Excited. Okay. Three S, 3px, 3py and 3pz. Okay. Then 1 electron each. This is 3d orbital. So next what will happen? These orbitals hybridized. So 1s, 3p and 2 3d. Okay. And form 6sp3d2 hybrid orbitals. These 6 hybrid orbitals, okay, then overlap with p orbital of fluorine atom, okay, and form 6 SF sigma bonds. Will be like this. So these 4 SF are in one plane and 2 are above and below the plane, and the shape of the molecule is octahedral. Geometry is octahedral, making an angle here 90 degree and also make an angle of 90 degree here. Okay, this will be the shape of SF6. Okay.